We're going to look at again today how to identify slope from a table in a graph and now create an equation for the linear equation in the form y equals mx plus b. Now, when you're given a table, not always are you going to be given a table that includes all x values in it. Like if we were to start, with 1, 2, 3, 4, 5, and so on. Sometimes what you're going to see is bits and pieces of a table which you then have to add to find all of the numbers that you in fact need. So really what you're looking for is how to extend the patterns here. So this table gives a good idea of an example of that. Now this does go in order, and if you'll notice here, what's happening is we increase the ones, or as we increase the x's, they're increasing by 1 each time. So I would go ahead and assume that this pattern would continue, and from -1, I could move up to 0, and then from 0 I would move up to 1, because again that pattern of adding 1 each time would repeat. Now in reverse, if I go back from -6, I would start with -7. So again, that's having to add to my table. Usually the x's are not the hard part because again those are just increasing by 1 in its simplest form. The pattern really is in the y's. So what we want to look for is what's happening to our y values. So what I want you to see here, as we move from -10 to a -7, we are adding 3. And again, from a -7 to a -4, we're adding 3. From -4 to -1, we're adding 3. And that pattern should continue through the table. Otherwise, it wouldn't be a linear relation. So I could continue that pattern out to the numbers that I didn't know before. So we would say 5 plus 3 would give me an 8 here. And 8 plus 3 would give me an 11 for this value. Now, to go in the opposite direction, I'm again saying basically what number plus 3 would give me a -10. Or you can move backwards from that and say -10 minus 3 would give me a value of -13 here. So again, that's kind of how we're extending our table. Now, the whole point of doing this is that we put it in the form y equals mx plus b. That's our end goal. And remember, in this form, m is our slope, and then b is our y-intercept. And both of those numbers are very important when we come to graphing. So again, we want to be able to identify our m and our b. We find slope by looking at the change in y over the change in x. So if I'm looking at my table here, the change in the y value was to add 3 each time, where the change in the x value was to add 1 each time. So what happens here, we have a +3 over a +1 for our slope, which then just becomes a +3, because again 3 divided by 1 is just 3. So this is in fact my m value. Now again, that's found by looking at the change in y over the change in x. The b should be pretty easy to identify in your table. All you're looking for the b is where x is equal to 0. That's the important part. So if it's not on your table, you have to find it. In this table, it's located right here, and I did find this point. Now, the x is always 0, so the number that really matters is the y value, because that's my y-intercept. So here, my b is equal to 8. Therefore, if I know m is 3 and b is 8, I can plug it in the equation y equals mx plus b. And so I'm going to change my m to a 3, a +3x, and then my b to a +8, because again, that was my y-intercept. So when given the equation here, we would say it's y equals 3x plus 8. Now, not always is it as easy as it was just in the last one. Sometimes you have to add numbers to your table to find where the 0 would be. So what we're going to look at here, notice our x values. We have 1, 3, 5, 7, 9. So those are actually increasing by 2 this time. And our y values, we have 1, 5, 9, 13, 17. Before I find my change in y over my change in x, which I could go ahead and find based on this, I am going to extend it to where I can see where my 0 is at, because again, that 0 becomes really important when identifying the equation. So I'm going to expand my table out so that I include all of these numbers. Now, the numbers that I did know were 1, 3, 5, 7, and 9. I'm not going to fit 9 on here, but that's okay. The reason I spaced those out is, if you'll notice, our even numbers have to fall in between them. This would be 2, this would be 4, this would be 6, and this would be 8. And likewise, going one pass to the left would give me 0, and that's really the one I'm looking for there. So what I want you to see here is the change that's occurring from here to here, from here to here, and then here to here. So as we move from 1 to 5, that's an increase of 4. From 5 to 9, again, an increase of 4, and 9 to 13, an increase of 4. So what has to happen then for it to fall in between is we're looking for basically half of that. What's in the middle? So the middle numbers between 1 and 5 would have to be increasing by 2's because, again, that would be half of that. So 1 plus 2 would give me 3. This would be 5, 7, 9, 11, 13, and 15. And if I wanted to go backwards, then this would be a -1. Again, because I want that to add 2 to get 1. So this would be the table extended out so that we see all of those values that we're looking for. Now again, to find my change in y over my change in x, or my slope, I'm looking at how the y values change versus how the x values change. So my y values here are actually increasing by 2, so it's a positive 2. And my x values are increasing by 1. I simplified it down to 1. So the slope then this time is 2 over 1, or just 2. So our m is equal to 2. Now to find the b, remember all we're looking for is to identify where the x is 0. And that's right here on my table. I extended it out to find that. So our b then is actually a -1. So when I'm looking at the equation, I have y equals mx plus b. My m has changed to 2, so I have 2x. And then my b is a -1, so that's going to be -1. So this would be my equation for this one. All right, let's try this one now. So this one we have, for our x values, 4, 6, 8, 10, 12. And then our y values this time are very small. We have -1, 0, 1, 2, 3. So they're actually only increasing by 1 on the y value. So this is going to make this one a little bit different. I'm going to go ahead and extend my table out, though, so that I can fit numbers in it, and especially 0, because that's where my y-intercept is at. So this one, because my y values are actually so small, I don't want to break it down too far. I'm not going to actually add the odd numbers in simply because I don't need to, because if I move backwards, I'm going to end up going to 0 just by counting on my odds. So our table starts at 4. So we know 4, -1, 6, 0, 8, 1, 10, 2, and 12, 3. So if I move back 1, this would give me 2, and I move back 2 more, and this would be at 0, which is really what I want to see. So again, because these values are actually increasing by 1 each time, I'm going to go ahead and do the same over here so that I can find these values. Now, to go backwards, I would actually subtract 1. So 1 minus 1 would give me a -2 here, and then -2 minus 1 would give me a -3 for that value. So again, I can only extend it out so much just because my y's were only increasing by 1 this time. So let's look again at how to find the m. And remember, m is just your change in y over the change in x. So if I'm looking at this table, then my change in y is actually a +1. So we were adding 1 to our y value, while our x's are actually increasing by 2 each time. So this is going to be a fraction. We have 1 over 2, which is going to stay as 1/2. So my slope, or my m value then, is 1/2. Now, my b again is where the x is equal to 0. And again, I found that by adding to my table. So the b here is going to be a -3, because that's what y equals, where x is 0. So the final equation for this in y equals mx plus b form would be y equals, m is 1/2 in this case, x, and then because b is a -3, I'm going to put -3. So this would be the equation for this one. Let's look at a graph now. So a graph is actually even simpler than a table. Remember, the whole goal of this is to get it in the form y equals mx plus b. So the way I'm going to do that is identify first my m, which remember m is just the change in y over the change in x. So here's where I make my stair step. Basically, I'm looking at how I move from this point to this point, which you should notice right off the bat is the line is decreasing. That means my first move is going to have to be to move down. So as I move here, I'm going to move down, and this is actually down 2, so this would be a negative 2. And then I move to the right 6. So right 6 is a positive 6. So my change in y is a negative 2, where my change in x is a positive 6. Now this is one where we can reduce it, but it will stay a fraction because the smaller number is on top. So if I reduce 2 over 6, I'd be left with negative 1 over 3. So my m here is actually negative 1 over 3. Now the b is really easy to find. All you're looking for is where it crosses on the y-axis. So basically where the line touches this line at, which notice it's right here at negative 4. So we found that just by looking at it and counting at 1, 2, 3, 4. So b is negative 4. So when I'm looking at my equation, y equals mx plus b, my m has changed to a negative 1/3. So I plug in negative 1/3 x, and my b has changed to a negative 4. So this would be the equation for this slope. All right, let's check this one out again. So again, in order to identify our equation in y equals mx plus b, I have to identify the m and the b. So remember, m again is found by looking at the change in y over the change in x. So on a graph, we look at how we move from one point to the next and basically making our stair step. So what you should know is this line is increasing, it's going up, it should be a positive slope. So as we move from the point on the left to the point on the right, we have to first move up, and we're moving up 1, 2, 3, 4, 5, 6, 7, 8 units. So that's up a positive 8. Then I have to move over 4 units. So that would be to the right 4, so it's a positive 4. So to find the change in y, we moved up 8, and to find the change in x, we moved over 4. So 8 over 4 is going to reduce to a whole number. So 8 divided by 4 is going to leave us with a slope, or m is equal to 2. Now again, the y-intercept is fairly easy to find. We just look at where it crosses the y-axis. And again, the y-axis runs up and down vertical. So we notice this graph crosses right here at a positive 3. So our b this time is equal to a positive 3. So if I'm looking at how to write my equation then, I have changed my y to a positive 2. So I'm going to start with y equals 2x. And then my b this time, my y-intercept is a positive 3. So I put plus 3 at the end. And this would be my equation for this graph. All right, last one we're going to look at. So this is again one of those different types of slopes. It's a flat line, so that needs to be kind of a bell that goes off in your head that you know that this is going to be a little bit different this time. Anytime we're done with a horizontal or vertical, it's going to be a little bit different. So here, again, to find our slope, our m, we're looking at the change in y over the change in x. So here's the deal this time. Because it's a flat line, there is no vertical change. We haven't moved up or down any. So the change in y is actually 0 this time. Now, the change in x, as we move either right or left, it really doesn't matter here, we're moving over 6 spaces. Now, it really doesn't matter what we're moving over because 0 divided by any number is going to leave us with 0. So our m this time is 0. We do still have a y-intercept. The line still does cross the y-axis, and it crosses right here at a negative 2. So our b is equal to a negative 2. Now, this equation in its actual form would be y equals, because the m is 0, I'm going to change it to 0x, and then b is negative 2, so we put minus 2. Now, here's the thing. I really don't need this 0x because, again, 0 times any number is going to be 0. So this part can be taken out. So what we're left with then is y equals negative 2. Anytime you see y equals in a number, it's going to be that horizontal line. And again, that's because there is no slope. It's just 0. So it's 3 different types of lines. Make sure you know and you can identify right away whether it's a positive, negative, or 0 slope, or in some cases, undefined.